Assalamualaikum, my name is Azlin Binti Ali. Title of this experiment is Conduction of Heat in Metals. Objective of the experiment: to apply Fourier law of linear in heat conductions. Second, to be able to understand how kinetic energy transfer in metals. Third, to show how heat transfer happen in metals. Apparatus of this experiment is metal spoon, kettle, matchbox and paper clips.
Assalamualaikum warahmatullahi wabarakatuh. My name is Daeng from Bachok and my number is E202010267113. And today I want to introduce you introduction of heat conduction experiment. So the heat transfer is the process of the movement of energy due to temperature difference. The calculations we are interested in include determining the final temperatures of materials and how long it takes for these materials to reach these temperatures. Typically, heat loss is proportional to a temperature gradient driving force or potential. Heat transfer can help inform the level of insulation required to ensure heat is not lost from a system. Next, conduction is the form of heat that exists due to direct contact without movement. The heat transfer process in which heat travels from particles to particle from the hotter end of an object to the colder without the actual displacement of the particles. Then the conduction of heat also takes place when two bodies of different temperatures are brought into contact. Conduction occurs in a solid, liquid or gas provided there is no bulk movement. Next, the methods of heat conduction experiment. First, we have to melt the wax of candle. Second, use wax to stick a few separated paper clips on the spoon. Next, let them cool down and stick it properly. Then, light the candle and place the flame of the candle at one end of the metal spoon. Then, we observe what happens next. That's all from me. Thank you.
For the result, as we can see, the paper clip closest to the candle flame drops down and subsequently the other clips start falling down one by one. This is happening because as the heat of the flame travels along, it heats up the particle of the metal which the spoon is made up of. This melts the wax, causing the clips to fall down. As the clips fall, the heat transfers to the next particle of the metal and then to the next, finally reaching the last clip where it melts the wax again, making it fall. For discussion, when one end of a metal is heated, the metallic ions gain energy and vibrate faster. Since ions are close together, vibrations are passed on to neighboring ion, which in turn begins to vibrate quicker too. Through the passage of kinetic energy in the form of vibrations, heat is transferred from the hot end to the cold end. Metals also have free electrons that gain kinetic energy at the hot end of the metal. These free electrons are highly mobile and can pass on their kinetic energy via collision with other electrons and metal ions as they randomly move throughout the structures. This greatly enhances the conduction process as energy is transmitted much quicker from one end to the other.
As a conclusion, it was found that the Fourier law explained the behavior of the temperature in the linear and radial heat conduction. The temperature gradient in the linear heat transfer was found decreasing along the material from the hot surface end to the cool surface end. The heat transfers also depend on the area of the cylinder, where the higher the area, the more the heat can be transferred. The radial heat transfer also exhibits the same result as the linear conduction. The temperature gradient of the brass was also found to decrease away from the heat source to the outermost radial displacement.